In the code, we have the input stream of 0, 1, 2, 3. Then we put it into array of digits. Then we have the frequency 1 and frequency 2 according to the input digit with respective encoded tone, frequency 1, frequency 2 as follows in the table. So we put an array for frequency 1 and put the array for frequency 2. Afterwards, we pair the frequency of 327, 757 together and 417, 877 together in this code to make it into a tone pair. Then the tone pair we display into the terminal. Afterwards, we set the parameters for encoding the digits into the respective frequency. So we set our sampling frequency of 44,100 Hz, duration of 0.5 seconds. Then we generate the time vector t equals to 0 until 1 over frequency, sample frequency in the duration. Then we encode the digits into the respective frequencies of the following pair. So we save it into encoded pair 1, encoded pair 2, and finally we put it into the matrix of encoded tone. Then we plot the waveform for each encoded tone pair separately, so we can hear the sound of the first frequency and the second frequency. For example, digit 0, 327 and 757, and then 1, 417 and 877, and etc, etc, to see that the pair of the each digit. So this is the tone pair 1, tone pair 2, tone pair 3, and tone pair 4. So now we need to actually combine the tone pairs together. So we use another code. So now we combine the frequencies for the two tones for each of the input digit. So we use the following formulas and then combine them into the combined tone, and then recombine them into the matrix of the encoded tone. So now we should get one singular tone for each pair. So this is tone 1, the combined frequency, tone 2, tone 3, and tone 4. This is for the encoding part. Now for the decoding part, here we set the parameters for 31012 according to the example, but our frequency is on our given table. Then the following code is the same as before, except for the decoding part. So the decoding part, we will decode the encoded tone previously and retrieve the original in digits. So for line 61, we set for the repeated function for 1 to 5 because there is 5 digits to decode, 31012. Then we set the iteration for the indices for the tone segment, then extract the current tone segment into the encoded tone. So this is the encoded tone, then we set the segment for the start and end. Then we correlate together into the array and matrix. So we set the size of the matrix for frequency 1 and frequency 2. So then we set the tone segment adjustment so it can combine easily. Then we set the correlation together and combine the tones. Then finally, indices of the minimum correlation value is put in the minimum value and sub together in the correlation size. And finally, we put the decoded digits with the correlation 1 and correlation 2. And finally, we plot the figure with the end length with the tone segment depend on how long is the frequency and the time length for each iteration of the pairs. Then the frequency is as follows. Then we use the FFT shift and FFT function in the tone segment to compute the transform of the tone segment. Then we plot the frequency against the tone segment, the converted tone segment. And finally, we put the limit on the x-axis to -1500 to 1500, so it can easily be monitored. This is our combined input digits, tone 1, 2, 3, 4, 5, which is 3, 1, 0, 1, 2. So we have 646 and 1086, which is close to our table. This is for number 3, so 647. So the decoded values is 646 and 1086. So it's a close value. So this is the first digit. Then the second digit is supposed to be 1. So it's 418 and 876. So 418, this one is 417 and 877, but this one is decoded as close to the value, which is input digit 1. Then this one is 756 and 326. 756 and 326. So as close we get 757 and 327, so this one may be 0. This one is 418 and 876. As close to ours is 417 and 877 is 1, and 518, 918 and 518. So as close to our table is 917 and 517. So when we look to the terminal, you can see that our message stream containing the input digits 31012. Then the tone pairs is arranged according to the matrix. Then the decoded digits. Then the paired decoded digits 31012.